Okay, geometry, we're moving right along with section 8.5. This is going to go really hand in hand with section 8.4 when we started talking about SOHCAHTOA, so that's going to be really important. I'm going to put that over here. SOHCAHTOA, but these are more in particular like story problems or like applications to SOHCAHTOA. And I know story problems, you freak out, but really this is kind of like why we even would use SOHCAHTOA in the first place. So these are real life kind of examples of when you would use SOHCAHTOA. So they first start talking about like angles of depression and angles of elevation. So an angle of depression, if I take like a horizontal line straight across and think about like depressing that down, okay? To depress something means like to lower. So I'm going to put lower next to depress, which means I'm lowering that angle down, and this is going to be an angle of depression, okay? Now, at the same time, if I have a horizontal line, like this bottom one here, and I say to elevate that line, okay, that means to raise it up, okay? So there's kind of like a hinge here. At the top one, there's like a hinge here. So this hinge, if I elevate him up, I'm raising it up. So I'm raising this guy, and this is going to be an angle of elevation. So from the horizontal raised up, from the horizontal lowered down, okay? Those are angles of elevation and depression, okay? All right, so example one, Leah is meeting friends at a castle at the center of an amusement park. She sights the top of the castle at an angle of elevation, which is 38 degrees. Okay, so I don't know if you can see this little triangle going on right here, but this angle of elevation is 38 degrees, okay, from the horizontal up. From the park's brochure, she knows that the castle is 190 feet tall, but she is 5.5 feet tall, okay? So they're wanting us to solve for how far she is from the castle, which is this distance right here at the bottom, okay? Now the thing that we need to consider is if we make a triangle out of this, this length on the side here is not going to be 190, okay? Because that's from the ground up, and she is 5.5 feet tall. So this 190 is no longer 190. We would have to subtract 5.5 feet, okay? 190 minus 5.5 would be 184.5 is what he's going to look like, okay? So if I just redraw this out so that I get rid of all the clutter, okay, I have 184.5 on the side. Okay, kind of hard to see. X is on the bottom, and then I have a 38 degrees here, okay? And this is going to look really similar to the problem that we had in like section 8.4, okay? So we're looking at which trig function we need to use, sine, cosine, or tangent. So 38 degrees is my angle. This guy is going to be the opposite side. X is going to be my adjacent side. The hypotenuse side is over here, but we're not going to use him because we don't know anything about him. Okay, so opposite adjacent, which trig function are we going to use? Opposite adjacent is tangent. Okay, so I'm going to do tangent, and you always put the angle inside of tangent, which is 38 degrees. Okay. And then I do equals opposites. Opposite is the 184.5. The adjacent is going to be my x. Okay. Now, since x is on the bottom that we're solving for, okay, what I need to do is I just need to flip these two around. Okay, that's kind of the rule that we learned in section 8.4. We flip those two around, so x will be 184.5 divided by tangent of 38. And let's go ahead and plug that in. Right, 184.5 divided by tangent 38. And I get 236.15. 236.15. And that is going to be this horizontal distance here, which is in feet. Okay, and there we have it. Okay, so same thing as what we were doing in section 8.4, but now there's story problems involved with it. Don't let them intimidate you, confuse you. Just draw out what you're kind of trying to solve for, okay? Now this one is an angle of depression, okay? So a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. The angle of depression to the other person, so here's the person down here. They're saving this guy right here, okay? And then there's another person down here, and the angle of depression is 42 degrees, okay? Now, the way that this diagram is set up, if you see these like two lines going on here, those guys are parallel lines. And then this line right here is kind of like a transversal that's going between them, okay? So if this angle is 42 degrees, then this angle will also be 42 degrees, okay? Because they are alternate interior angles, right? So 42 and 42. So we can kind of note that that guy's 42 as well. All right, and the helicopter is 18 feet above the water. So they've labeled this side as 18. Okay, they want to know how far away horizontally that guy is. Okay, so we have this triangle going on here. I'm going to draw him off to the side over here without all the clutter. Okay, here's my right angle, 42 degrees, 18, x on the bottom. Okay, all right, so just like we did up above, we're going to set up our trig function. 42 is my angle. 18 is the opposite side, x is the adjacent side. Hypotenuse side is over here, but we're not going to use him. Okay, so I think we're going to end up with the same trig function as what we had up above. Opposite adjacent, we're going to need to use tangent. Okay, all right, so 42 degrees is what's going to go inside of the tangent function. And then I need opposite over adjacent, which is 18 over x. Okay. Same thing as before, I'm going to swap these two around because the x is on the bottom. I'm going to swap those two around. So x is 18 divided by tangent of 42. Okay, I feel like I'm kind of going a little fast here because this is something that we've already done before. But if I'm going too fast, pause the video and collect your thoughts. There you go. 18 divided by tangent 42, and we get 19.99. And that is also going to be in, I think, feet. Yep, in feet. So that's how far horizontally they would need to take the helicopter and move him over 19.4 feet to be right above this guy, or 19.99 feet. So about 20 feet. They need to scoot over to get to that guy. Okay? All right, now this next one. Using two angles of elevation. So now we kind of have two triangles going on here. I don't know if you can see these, but we have this inside one. I'm going to label him in orange, okay? And then, I'm going to label him in orange, and I'm also going to draw out what he looks like with all his labels and stuff. So we've got Y down here. I don't know if you can see that this is labeled Y, that bottom, okay? This guy is 70 degrees, and here's my right angle there, okay? And then X is this top side, okay, or that tall side, not the hypotenuse, but the tall side. Okay. Now I'm going to do the other one in green, and he is a longer triangle. Okay, but he is this right triangle here. So still a 90-degree angle. I'm going to draw him out and see what he looks like. Okay. His angle down here at the bottom is 26 degrees. And then I have X is this height right here. Okay, now this is the tricky part. This bottom side right here is not 10. Okay, that bottom side right there is not 10 units. It is actually 10 plus y. I don't know if you can see that very well, but the length from here to here is 10. From here to here is y, so this guy will be 10 plus y. Okay, so what they're wanting us to do, we haven't even read the story problem yet, to estimate the height of a tree. Oh, estimate the height of a tree, that's what we're solving for. We're solving for kind of that x there, okay? Mrs. Long sights a tree's top at a 70-degree angle of elevation. She then steps back 10 meters and sights the top at a 26 angle of elevation. If Mrs. Long's line of sight is 1.7 meters above the ground, okay, I'm going to circle that, 1.7 meters above the ground, because we're going to have to involve that at the very, very, very end, okay? So keep in mind this 1.7 meters here. We're going to use that here in just a minute. But how tall is the tree to the nearest meter? Okay, so, oh boy, we've got lots of variables going on here. But let's just start with this orange one, this orange guy. Okay, the only thing that I can do with him is look at the 70-degree angle. I can look at X, which is the opposite side, and Y, which is the adjacent side. Okay, the hypotenuse side is the one that we're not going to use. So again, we have a tangent function, right? Okay, so I'm going to set him up over here. I'm going to say tangent of 70 degrees, and I'm going to write him out as opposite over adjacent, which is X over Y. Okay, all right, now that doesn't really get me anywhere because I have X and Y going on at the same time. Okay, so let's see if we do the same thing for the second one, this green side. I should have put that in orange, but whatever. If I do the same thing for this green guy, we have an opposite here and adjacent here. okay, for the 26 degrees. And if I write him out, he will be tangent as well, but I'll have tangent of 26 degrees will be opposite is x over the adjacent side is 10 plus y. Okay, now I have these two equations, and both of them involve x's and y's, but what I can do is if I solve for x and get x by himself over here, okay, this I would have to multiply the 10 plus y to the other side. All right, so x over here will be equal to 10 plus y times tangent of 26. Okay, that's what he will look like. Okay, now this x, if I solve for this x over here, and I multiply the y to the other side, this x will be equal to y times tangent of 70. Okay, but then we know that this x will be the same height as this x, right? Like this height right here for this triangle is the same as this height here for this triangle. So if x is equal to this, and x is also equal to this, isn't it true that these two things are equal to each other? Okay, so I can basically kind of get rid of my x's altogether and say that this guy is equal to this guy. Okay, so I have two things that are equal to each other. And what I'm going to do is, to simplify things just a little bit, I am going to go ahead and figure out what tangent of 70 degrees is and get it as a decimal. Okay, so I have y times tangent of 70. Okay, tangent of 70 is 2.75. So really, if this is 2.75, I really have 2.75 y over here. Okay, and then over on this side, tangent of 26 is 0.49, let's say. 0.49 is what tangent is over there. Okay, so what I can do is, since I have 10 plus y over here, I'm going to need to take this 0.49 and distribute him through for both of those pieces. So I'm going to take 0.49 times 10, okay, which is just going to involve moving the decimal one place. So this is going to be 4.9, okay, and then 0.49 times y is just 0.49 y, okay. All right, so I went from being something really ugly to something that's kind of nice. It's got some decimals, but then I want to join my y's together. So I have a y here and a y here, okay? And I'm going to move the 0.49y to the other side, okay? And 2.75 minus 0.49 is going to give me 2.26y equals 4.9. Okay, then think about how you would get y by itself. If we divide by 2.26, we get 4.9 divided by 2.26. There's a lot of calculator work. Y is going to be 2.17. Beautiful. There we go. Okay. All right, so we're almost there. Y equals 2.17. Beautiful. I'm going to look to this smaller triangle here because I really could do either one. It doesn't really matter. But this one, since it has a 10 plus y, I'm not going to worry about him. I'm going to worry about this one. This y is going to be 2.17. Okay. Now, if I want to solve for x, okay, I know that x is going to be equal to y times tangent of 70, or y times 2.75, right? If I'm trying to solve for x, okay? Well, if y is 2.17, I would just take 2.17, move my hand so you can see, 2.17 times the 2.75, and that will give me x, okay? Because that's what I have written out here, all right? So 2.17 times 2.75, and I get 5.97 is what x is going to be. X equals 5.97. Oh man, we were so close. Okay, so this x right here is 5.97, and we are trying to find how tall the tree is. Okay, so does 5.97 tell me how tall the tree is? Not quite. Okay, this is where the 1.7 meters comes into play. So there's an additional 1.7 meters to get to the ground. This is 1.7. Okay, so if 5.97 is here and 1.7 is here, we're going to need to add those two together to get the final answer. Okay, so final answer, I think 7.67 meters. Yes, 7.67 meters approximately is how tall that tree will be. Okay, so that one was a little bit more work just because we had two of them going out at the same time, and then we had a second equal to each other. So this is going to be a really advanced problem, but I think most of you guys can handle it, so I wanted to go through that one anyway. But that's all I have. There's no backside to this, so there you go.